The next topic is compounds nomenclature. There is two types of compounds, ionic and covalent. As I mentioned in a previous video, ionic is the bonding between a metal cation and a non-metal anion. And covalent is the bonding between a non-metal and another non-metal. Within ionic, we have four types of ionic compounds. In this video, I will talk about type 1 and type 2. Type 1 is where the cation has only one type of charge. Type 2 is where the cation has more than one type of charge. In another video, I will talk about polyatomic ions, which is the ion compounds that have more than two types of atoms, and also some acids nomenclature, specifically the acids that contain hydrogen ions. And in a third video, I will talk about covalent compounds. So let's get started with type 1 and type 2 ions. Let's look at some common cations and anions. First, we have the type 1 cations, which are cations that only have one type of positive charge. They are mainly in groups 1 and 2. We can see that in group 1, all of these cations have a +1. In group 2, they have a +2. Then we have some transition metals, like zinc, cadmium, and silver, and also aluminum. Then we have type 2 cations that have more than one type of positive charge. So among them we have tin, lead, mercury, copper, cobalt, iron, and then we also have chromium and manganese. These actually have more than two types of oxidation states, but these are just examples. And then we have other transition metals that are not shown here. And finally, we have monatomic anions, which are the nonmetals that bond with these metals, and they have negative charges. Let's write some names of type 1 ionic binary compounds. So we have three examples here. The first one is beryllium and chlorine. So the indications say write the name of the cation. Okay, so beryllium is listed as one of the cations with one type of charge. Beryllium is right here. So we write beryllium. And then for chlorine, we write the name of the anion with "ide" ending. Okay, so chlorine takes the name of chloride. So this becomes beryllium chloride. Okay, the next one is aluminum and nitrogen. So we write aluminum, just the name of the metal cation, and then nitrogen takes the name nitride. Finally, we have silver and sulfur. So we write silver sulfide in this case, which is the one right here. Okay, the last thing is we can check for the neutrality of each of the compounds. So let's start with the first one. So beryllium has a charge of +2. So we can write a +2 on top of beryllium. And the chlorine has a charge of -1. So we write -1 on top of the chlorine. So beryllium, let's say there is one atom here, is implicit, and there is two atoms of chlorine. So we multiply the 1 from the beryllium times the number of top, the +2, and we get +2. And then the 2 in the chlorine times -1, the number on top, and we get -2. So that equals 0. So this compound is a neutral compound. The next one is aluminum and nitrogen. So aluminum has a +3 charge, and nitrogen has a -3 charge. Then the ones here are implicit, so we multiply the 1 in the aluminum times the +3, and we get +3. and then the one in the nitrogen times the -3 on top, and we get -3, and that gives us 0, another neutral compound. Finally, we have silver and sulfur. So silver has a +1 charge, and sulfur has a -2 charge, and then is 1 sulfur. So 2 of the silver times a +1 charge, we get +2, and then 1 of the sulfur times -2, we get -2, so this is equal to 0, also neutral. We can also write the formula from the name of the binary compound. So for example, we have lithium oxide. So lithium has a +1 charge, so we write lithium plus, and oxide is oxygen with a 2- charge. So what we do is we cross the numbers, the 2- to the lithium and the +1 to the oxygen. So we get lithium 2O1. So let's check for charge neutrality, just like before. So we have a +1 for the lithium and a -2 for the oxygen. So we multiply the 2 from the lithium times the +1, and we get +2. And multiplying the 1 from the oxygen times -2, we get -2. So adding this up is 0. So this ionic compound has to be neutral. So we get a charge of 0, so that makes sure that this is the correct compound. So lithium oxide is lithium 2O. The next one is sodium phosphide. So sodium has a +1 charge, so sodium plus, and then phosphide has a 3-. So phosphide 3-, and so we cross the 3 and the 1, and we write sodium 3 phosphorus, and then there is a 1. So let's check for neutrality. So we have a +1 for sodium and a -3 for phosphorus. Okay, so multiplying 3 times +1, we get +3, and then 1 times -3, we get -3. So this is 0. So it's sodium 3P, and this is sodium phosphide. Okay, and the last one is potassium iodide. Potassium is a plus charge, and iodide negative charge, -1. So we cross these, and it's a 1-1, so Ki. And checking for the charges is a positive and a negative, and this is a 1-1. So we get +1 -1 equals 0. So this is Ki is potassium iodide. Next, we have type 2 ionic binary compounds. Type 2 are cations that have more than one type of charge. So, for example, we can have iron with 3+ or iron with 2+. Let me give you an example of the 2 ways that you can write the name of these different compounds. So let's look at iron 2, oxygen 3. So the first thing that you have to do is to find the charge of iron. And there is an easy way to do it. Look at the subscripts of both iron and oxygen, and the subscript of oxygen, just cross it to iron and make it positive because it's a cation, and the 2 goes for the oxygen and it's negative because it's an anion. So the charge of iron is +3 and the charge of oxygen is -2. And this compound must be neutral, so the total charge must be 0. So to check that, multiply 3 times -2 is -6, and then 2 times +3 is +6, that equals 0, which is fine for a neutral charge. Okay, so we know that the charge is +3 for iron. Okay, so we look at the names here, iron 3+. The first type of name that we can write is iron and then the Roman numerical. So iron 3 for the +3 charge, and then for oxygen, we know that it has to be oxide. Okay, so iron 3 oxide. The second way to write the name is if we have the lower charge, we put an OUS at the end of the metal name. And if it's a higher charge, we put an IC at the end of the metal name. In the case of iron 3+, it's the higher charge, so we put ferric. So it would be ferric oxide. The name of the anion doesn't change. The next one is copper and bromine 2. So again, we find the charges, +2 for copper and -1 for bromine. Okay, so it would be copper and 2 bromide. And writing it the second way, so copper 2+ is the higher charge of the two, so it would be cupric. Cupric bromide. The last one is lead and phosphorus. So we cross the charges, +2 for lead and -3 for phosphorus. So we would write it the first way, lead, 2 for the charge, phosphide. And the second way, so lead is the lower oxidation of the two. Between 2 and 4, 2 is the lower. So it would be plumbous phosphide. Plumbous phosphide. Finally, we can write the formulas of these type 2 ionic binary compounds if we are given the names. Let's look at the first example, cobaltic nitride. So the IC in cobalt tells us that we have to choose the higher oxidation state. So the higher oxidation state of cobalt is 3+, cobaltic. So we have to write cobalt 3+. And then nitride, from the previous list of anions, we know that is a 3-. Then we cross the charges, the 3- to the cobalt and the 3+ to the nitride, and we write positive numbers for both. So cobalt 3, nitrogen 3. But then we have to write the most simplified form of this compound. So we can divide by 3 on both. So that will give us cobaltic nitride as cobalt and nitrogen 1:1. Finally, we can check for neutrality of the charge by putting the +3 on the cobalt and the -3 in the nitrogen, and this is 1:1. So we multiply 1 times +3 is +3, and 1 times -3 is -3. So that would give us 0. So cobaltic nitride is cobalt and nitrogen 1:1. Okay, the next one is copper 2 chloride. So 2 represents the +2 charge of copper. So we put copper +2. And then chloride is -1, based on the previous list of anions. Then we cross the charges. So we get copper 1 Cl2. The last one is tin 4 sulfide. Okay, so this one is tin and the charge is 4 plus, and sulfite we know that is 2 minus. We cross the charges and we get tin 2, sulfite 4, and we need to get the smallest form of the subscripts, so we divide both by 2, and we get tin S2. So this one is the final form of tin 4 sulfite. Try these problems yourself. Here are the answers.